Hello guys, in this very lesson, we're going to be solving the third question we're given as a take home in our previous lesson on circular motion under physics. So if you want to test yourself, I'll give you some time to do that right away. Okay guys, let's see how many solve this question correctly. So let's see what we have right here on the board. A stone rests in a pill that is moved in a vertical circle of radius 60 centimeters. What is the least speed the stone must have as it rounds the top of the circle if it is to remain in contact with the pill? Now, first of all, let's try to understand what this question deals with. Now, don't forget we're talking about a uniform horizontal circle here. That's what we're talking about. Although we didn't derive a formula that looks like this question exactly, there's no perfect formula that fits this. But this very question looks very much like the Ferris wheel that we talked about, and even a string, and even a pendulum bob being weird or being pulled by a string. This looks very much like that. So if you have seen those very lessons, I'm very sure that you have an understanding, of what to do. You have an understanding of this question. You know what to do actually when it comes to solving this. So we have a stone resting in a pail, and the pail is being weighed like this, vertically, not horizontally, like this. Don't forget, if you look at the stone is not being said in this question that there was any string or any stuff being attached to the stone. So just a free stone, in a pail that is being weighed vertically like this. So if that is what we have, that simply means there is no tension anywhere. There's no tension anywhere here. There's no string. And also, it's not a Ferris wheel whereby we have a normal reaction. We're trying to keep the stone moving in a circular path. What we have right here is just the weight of the stone doing the whole circular motion. So this is what it is. The weight of the stone will bring about the centripetal force, which is the change of force. So the weight of the stone is equals to centripetal force, which is mass times centripetal acceleration, or radial or angular acceleration. So centripetal acceleration is velocity squared, that's linear velocity squared, over radius. So the weight, which is mass times gravity, equals to mass times this over this, that's velocity squared over radius. So mass takes some mass. We have this gravity equal to velocity squared over radius. So cross multiply. So the linear velocity squared is equals to gravity times radius. So linear velocity squared is going to be square root of gravity times radius. This is the formula we're going to use. Now the reason why this is very simple and direct is that there's no string attached to the stone. That's the first thing I want to note. And it's not like the Ferris wheel whereby the body is being seated on the seat and there's a kind of movement. No, the body is just being put, the stone is just being attached in the pail, and the pail is being weighed, vertically. So that's why I just have this. So it's only the weight that brings about the centripetal force. Without the weight, there will not be centripetal force. So quickly, we have gravity to be 10 meters per second squared. That's a constant, nothing changes it. And the radius of the circle is 60 centimeter. I'm going to move this to meter. Divided by 100 is 0.60 meters. That's the radius. So we're going to fix it in. So we have the V equals to gravity 10 times radius 0.60 meters. So what do we do next? So the velocity is 10 times this is 6 meters. So what's the velocity? The velocity of this square root of 6, that'll give us 2.449. So that's 2.45 meter per second. That's the absolute answer. So don't forget, what's the question? What is the least speed? So the least speed that is needed for this very stone to remain in the pail, to keep moving in that vertical, circular motion, that vertical circular path, is 2.45 meter per second. Very simple and direct. So that's everything for this very lesson. So if you found this lesson helpful, please give me a follow at Revelation Hub. That's on Facebook, and also subscribe to this very channel at EduMosaic. So that'll be all for this very lesson. See you in the next lesson. Thanks.